Alright, this is the lesson on using decay to estimate ages. Please spend a few moments reading the first page with the purpose, relevance, success at the top, and a little bit of explanation on the process here. Please pause the video while you read that over. Example number 1 was worked out for you. Here's example number 2. A rock is estimated to have contained 800 grams of potassium-40. It now contains only 100 grams. How old does the rock appear to be? So we write down what we estimate it originally had, 800. And then we cut this in half repeatedly until we get down to the current amount of potassium. So cut this in half once and we get 400. Cut in half again and we get 200. And cut it again and we get our 100. So we had to cut the original amount, 800, in half 3 times to get down to the original amount. Now this cutting in half, that takes a certain amount of time according to whatever the material is. Potassium has 1 time to cut in half, and argon has another, and uranium has yet another. If we look at our chart here, it says that potassium towards the bottom takes 1.25 billion years to cut in half. And so we write that down, 1.25 billion. And this next swoop, it gets cut in half in the same amount of time. And then the third time, again, 1.25 billion years. So we have 3 swoops. Each represents the same amount of time, 1.25 billion. So you multiply 3 times that, and you get 3.75 billion years is how old this rock appears to be. This is not proof that it happened that long, but it is a reasonable guess. Number 3. A rock is estimated to have originally contained 800 grams potassium-40. It now contains 300 grams. The rock appears to be between. Okay, now we start off with the same amount of potassium, 800, so we can use this chart up here. But notice that as we cut this in half and half and half, we don't get to be exactly 300. 300 grams would be somewhere in there. So it is older than 1.25 billion, but it's not 2.5 billion. 2.5 billion would get us to be too small of a number. 1.25 would get us to be too big of a number. So it's going to be somewhere in between 1.25 billion and 2.50 billion years. Okay, please pause the video now as you read the next section about carbon-14 dating. It's basically the same process, but there are a couple extra pieces of information that make it special compared to the other dating methods. Okay, so let's look at the example 5 with this. An ivory sculpture is unearthed. Now ivory, that's made from tusks. So it's made from animals, and so it can be dated with carbon-14 because the animals at some point were taking in that material with their eating of food. Anyway, it's estimated that such an item would contain 16 moles of carbon-14. Remember, moles is a quantity like dozens, and you learned about that in chemistry class. Analysis shows that it actually only has 8 moles currently. How old does this appear to be? So this is a very short little process. We start off with the 16 that we think it originally contained, and we cut that in half, and we end up with the amount that it currently appears to have. So we cut the original amount in half once, and that is over a half-life of carbon-14, which is 6,000 years approximately. Remember, the 6,000 years isn't exact. It's actually 5,900 something, something, something. But just for the ease, we're going to do 6,000. So it appears to be 6,000 years old. Example number 6. An archaeologist digs up a campfire site with many bones. It's estimated that the bones should have 10 moles of carbon-14, but they actually only contain 1 mole. The bones appear to be between how many years old? So write down what we think it originally contained, and we cut that in half. We're not down to the 1 yet, so we cut it in half again. We're not down to the 1 mole yet, so we cut in half again. We're not down to the 1 mole yet, so we got to cut in half. Okay, now we're smaller than the 1 mole that we currently analyze it to have, and so we stop our swoops. Each swoop, each cutting in half, takes carbon-14 6,000 years. So the 1 mole is somewhere between 3 and 4 swoops. So it is between 18,000 and 24,000 years old in its radiometric apparent age.